What other types of waves do we have? Yeah, Jack? Radio waves. Yeah, so another type. Radio waves, sound waves. Austin, you had your hand up? Microwave, okay. Love it.
Ocean.
What we got? Lots of times now. Dane and Tamia, I'll get you each to say one. What's that, sorry? Heat waves, yeah, and Dane? Tsunami. Hey, I like it. So we got, just gonna keep going down here. Heat. And I'm gonna say tsunamis, big ocean waves. Tsunamis. Boom. Bronson. Light waves, I love that one. I'm gonna put it over here. Down here, actually. Light. What else? Sam?
The wave file.
The what? Say that again?
The wave file format.
The wave final format.
File.
Oh, it's file.
It's a sound format.
Okay. I don't even know what that
That doesn't make sense.
Wave.
It's when you're like recording things, like for like videos.
Yeah.
The waves that you see.
Oh.
The wave file format. Okay.
There's no E on it. It's just WAV.
Like that? I
Yeah.
thought you meant on file. I almost took the E off the file. There we go. Jacqueline, another one? Airwaves, okay. So, okay, I'll just put it down here. Air. Yeah.
Ultraviolet waves.
Ultraviolet. There we go. So that's kind of branching off of light here. So we're getting ultraviolet. Love it. Yeah.
Sonar.
Sonar. Yeah. I don't even know.
I think that's close to sound, but.
Yeah.
But
I'm not
they
sure.
use it
I'm
in
just
the
gonna write it
ocean. I
down
just
here.
know that.
Okay. I love it though. I love it. Sonar waves. Anything else? So we got a ton of types of waves. What do we know about any properties of waves? How waves move? What they actually do?
Vibrate.
What's that, sorry?
Vibrate.
They vibrate. Okay. So I'm gonna just put that here.
Certain
Actually,
frequencies,
vibrate.
I guess.
We can't see them.
You can't see what?
We can't see a lot of the waves.
You can't. Okay. So sometimes you can't see them. I'm just gonna say invisible. Does that work?
Yeah, can't always see. But like, if you talk about ocean waves,
Frequency
they're invisible.
changes.
Yeah. Yeah. Okay. So invisible. I'll just put a question mark beside it. Okay. Anything else we want to add to this? Yeah, Tanner.
Frequency changes the speed they travel at.
Ooh, I like that.
Sounds very good.
What?
There we go. Thing doesn't work very good, does it? So you said they change speeds.
Due to
Okay.
frequency.
Ooh, there's a good word. I'm just gonna write frequency up here.
Big brain.
Big bird though.
Frequency. I'm gonna write speed up here too. What's another more physicsy way to say speed? Like
Velocity.
velocity. Yeah. So, what is velocity? What's the difference between velocity and speed? Do we know that?
Oh, I
Velocity,
wrote it
not
down
like
last year.
weight times like how fast it's moving.
You're onto something there.
Oh,
Does anybody know the difference between velocity and speed?
I remember it from last year, but I
Yeah.
can't.
We'll get into it later
I probably have
in
it in
physics and the
there.
waves.
I
portion,
definitely have
but
it in
I'll leave it at that for now. I'm gonna get this going again.
Hey, why did you want to say no? Because teachers were worried about parties.
So what my plan is we kind of started a concept map there, and we're gonna come back to it after we do some more things about waves. Once we work with the slinkies and work with a couple different things, then we'll come back to that and learn about it. Okay. So for now, let's see if this works.
Press the thing up.
Boom. There we go. So why are we able to see? Eyes. what are our eyes seeing though? What, light. Okay, and what is light? Lights are waves. Boom. Okay, so we're gonna talk a lot about what lights. It's kind of a wave. We can put it in there because light can travel as a particle and it can travel as a wave. Later in this unit, we're gonna talk about what that actually means and why that occurs.
Are we meant to write this down?
No, you don't have to write this stuff down. We'll do a little example after, and I'll get you to put some of that stuff down. But this is just, we're just setting stuff up. So what is a wave? You probably should write this top one down. A wave is a disturbance that carries energy from place to place. That's what a wave is technically, okay? And we're gonna get into how that energy is carried, and why it happens.
But like, what do you think?
Yeah, I don't, it's not gonna switch.
Clay, I was so close to wearing my glasses today too.
Awesome. Okay. No, okay, yeah, you're okay. So it's a disturbance that carries energy from place to place.
So it pushes matter.
It pushes matter, yeah, potentially. Potentially not though.
Matter follows
We'll look at that.
it.
No, okay.
Oh,
Cardinal, you give me a thumbs up, buddy, when you're ready to roll. Yeah? Okay. Awesome. So these are some of our, you probably can't see them very well up there, but these are the essential questions, okay? So what I'm going to do for the rest of this portion is I'm going to give you essential questions, or basically what they are at the end of the unit, these are the deep level of understanding that I want you to have. You should be able to have an answer for these things, and they're not going to be easy to answer. So I'll just read a couple, like, why is spear fishing so difficult? Why is the fish not where it appears to be? I don't necessarily need an answer right now. We're going to look at all these things. Or how can we measure and predict waves with math? That won't be something that we do today, but it will be something that we get into, right?
So we'll just start away from that stuff.
No, I feel like the word math sometimes stresses people out, but don't worry, this is good stuff. We'll
We're
work
gonna
through
do
that.
like multiplying by the meaning and stuff, aren't we?
Yeah, there's some multiplication in it,
Oh my
but no, it's good. It's good stuff.
We did this
Um,
last year.
Another good one is, what is the role of waves and phenomena such as echoes, reverberation, or the Doppler effect? Has anybody heard of something like that?
What's the Doppler?
What is the Doppler effect? The Doppler effect, pretend that I'm an ambulance and I'm moving this way, so I've got my sirens on. You can't hear the ambulance very well when it's going this way, but you hear a lot of it in the background. So it's just the way that sound waves travel from a moving object. Does that make sense? Here, I'm gonna draw for you. So if this is my road right here, and this is my ambulance, I'm just gonna draw it like a circle, or I'll draw it like this. Okay, so the sound waves would look like this, like they're very bunched up at the start, but then they get longer and longer as it goes. Does that make sense? Because this vehicle is moving that way. Don't worry about it. We're gonna work on that in a couple weeks. But yes.
What happens when like a plane or jet breaks the sound barrier then?
Yeah, so this is the exact same thing. When a plane or jet breaks the sound barrier, basically they're going faster than these things, and they get past this first one. And that's when you hear that loud crack. There's a good video on YouTube. I'll actually show you that one later. But right now, we are getting rid of this stuff. We're going to talk about some of the different properties. And hopefully at the end, you'll be able to answer all these awesome, fun, and sometimes difficult questions. So, so we've got a wave here. Not a very good one, but we got one. I'm just going to put one through the middle here. There we go. Can anybody name some of the different parts of the waves, or some of the ways that we describe waves? What are some words you've heard? Like, I know, Tanner, you said speed, and then I've heard velocity, right? So that's one thing we talk about. We talk about how fast is this wave actually moving. So I'm just going to put that down here.
There's something I'm writing down right now.
Yeah. Actually, I want you to put this graph in there. Yeah. You might want to give yourself some space. Make it like half a page, I would say, would be my advice. If you're neat, it can be smaller.
Too late.
Okay. So we're going to talk about, I'm just going to make a checklist here for myself to make sure I get them all. We're going to talk about amplitude. we're gonna talk about frequency. Talk about nodes. What else do we want to talk about? So any guess on what the amplitude might be of this?
The top part of the
The
wave.
top part? Yeah. So where would I measure from, Cody?
The dotted line.
The dotted line, right. So the amplitude of the wave is basically how far it reaches off that normal. So it's the size of the wave, if you will. So right here, from here, down to the center, this would be the amplitude, okay? I'm just gonna write that up top. Or right here. That's the amplitude. Now, it's not just this way, it's also down. So this would also be the amplitude right here. Okay, so I'll just put I might go with a couple different colors so it doesn't get confusing. So we got the amplitude. What about the frequency? Yes, Dane. Yeah, so I like that. So he's just saying how what did you say? How fast they go like that? How frequently they go like that? Yeah. So what frequency is it's cycles per second. That's the unit for it. We call it hertz. Hertz, and that is cycles per second. I'll just go like that.
Sometimes you think about patterns per second too, like how many patterns do you see in 1 second?
Yeah, exactly. So in this case, the frequency of a wave like this has a very low frequency because the waves, that's one wave, are traveling, there's not a lot of frequency in it, but if we were here, that's got a high frequency because the wavelengths are closer together. Does that make sense? Okay.
What's the H2 cycles?
This is Hz. It stands for hertz. It's just when we talk about the frequency, instead of saying it has 10 cycles per second, we would just say it has 10 hertz. Hz.
Okay.
It stands for H-E-R-T-Z, hertz. Yeah, please do.
So what they're doing here, you guys, is this is the unit. So if we're counting and I say, okay, we're gonna time, on your mark, get set, go, and we go 1 second, and we count till there's 1, 2, 3, 4 patterns, then we say it's 4 in 1 second. So that's how that unit works. Now, somebody thought, I don't like that. I don't like the seconds on the denominator. So we could move it using some math and put a negative exponent on it, and then they probably said, well, I don't really like that neither. So let's call it a 4 hertz. So they just kind of created a new unit. So if you guys see hertz, your thought should be 4 over top of seconds. That's what it's for. Okay? I'm just going to throw one more thing in here.
Please do.
Anybody know what that line is?
The equal.
The average or like.
Picture this as water, because that's the most common wave we see, right? There's your water. What's it doing? It's at its standstill. So that line, when we draw it, is that standstill. We call it the rest position. But when we create a wave and it goes up like this, can you see where the amplitude is now? It went from the rest position and up. So it's kind of like how high up. And then eventually it will go back down. And then it'll go back up. And go back down. One last thing I throw in is, so if you put a little yellow rubber ducky on your ocean or the lake, he's going to sit right here at rest. Now I always thought this was the interesting thing about the wave. So as the wave goes forward, does he go forward too? No. He actually just rides up and down and up and round, up and down the whole while. So that's why in that definition, right, it said the medium or the material does not move. Just goes up and down, up and down, up. Now, if we go up toward the duck in the lake, how many have seen the duck go up and down and up and down? How many see the duck go forward? Nobody sees that duck float out, that little yellow duck float out to the middle of the lake? That's because there's other forces acting on it. There's undercurrents and things like that under the water. It circles and moves it forward, okay? So that's a hertz. A hertz, do you see hertz? You should say, oh, that's it, per second. Okay? And you guys, anybody that deals with sound, the stereos and things like that, you might kind of go, oh, hertz. I think I've heard of hertz before.
Yeah.
Okay. Not per minute, not per hour, it's per second.
Did everybody see what Miss Oviatt did here? This is a great way to think about hertz.
Yeah.
Everybody understood that one? Okay, awesome. If you don't, that's okay. Just ask us and we'll get you going on hertz. I figured when I was down here explaining hertz and frequency, I didn't actually explain wavelength to you. So how would we measure actually what one wavelength looks like? What would one full wave be? Any idea? Yeah?
In between the lines. Like,
Say that again?
in between like the top lines.
Yeah. So how I like to remember it is we can either do it crest to crest or trough to trough. Okay, so you're getting a whole bunch of different language here. Crests are up top, so any top is a crest. And any bottom down here, that's a trough. Sorry, it's a little bit messy. Now, what I said about measuring wavelength is we measure them crest to crest or trough to trough. So what that means is I just put a line right here, boom, and a line right here, boom. That's two crests. That is one full wavelength right there because it's crest to crest. And I can do the same thing on the bottom here. Go boom, and boom. And that would be one full wavelength here. Does that make sense for everybody?
It contains one complete pattern.
Yeah. So I would write that down here. I would go wavelength. I would just write one full wave or one complete pattern, and in this case we go crest to crest and trough to trough.
Again, sometimes I use the idea that it's a pattern because when we talk about sound waves, we don't call them crest and troughs anymore.
Yeah.
But they're still waves.
Yeah. Okay. We went over amplitude, we went over frequency, we went over wavelength. There's actually some equations. We're getting the math in already. Some equations that mix all the frequency and the wavelength and the speed all together. We'll get into that next week though. And then the last thing I want to talk to you about is nodes. Okay? So the nodes we'll talk about, basically it's just where we hit that resting position. Okay? So anytime the waves come over that resting position is a node. So we've got one here. Got a node. I'll just write it in. And then we also have something called antinodes. Okay, that's basically just the opposite. So anytime up top here, or on the bottom, right at the top of the crest and the bottom of the trough is an antinode. So I'll write that here. It's an antinode. So I wanted to just throw a whole bunch of language at you, a whole bunch of new stuff, just to get you familiar with it. But what I want you doing for this first day is kind of learning about waves on your own and exploring their properties on your own. I just wanted to give you a base or something to look at so that you're a little bit more familiar with that language. It's not meant to just dump this on you and make you feel anxious. So if you feel that way, that's okay, all right? Just know that we're going to go over this stuff, and it's all right if you don't understand all the terms just yet, okay? But what we are going to do is we have a Slinky Lab. Now, basically what it gets you to do is we've only got 5 Slinkies, and we've got, I think, 34 of you. So that is slightly problematic. So I found one on the internet as well. It's like a wave simulator. So what we'll do is we'll split up half the class, get half of you working on this together for about 20 minutes, and then half of you working on the online simulator, okay? I'm gonna hand this out quick, and then we'll go over it, and then we'll talk about how we're gonna split it up.
4 eyes. 4 eyes.
Okay, the worst part is you're not kidding.
So you're gonna watch after now?
Yeah,
After you hand out to the 4 of us?
Yeah, that's what I do every time. Hey, time, simulator. Corporate simulator. There you are, sir.
I cannot wait to all 4 weeks after this walk.
That one can't go in the trash.
Not the, I don't even know what's wrong with this stuff.
Listen, you guys, when you're using those slinkies, don't be horsing around with them, because as soon as